Hello, today we'll be talking about the species difluoromethane, which is CH2F2. We will start by first drawing out the Lewis structure. To be able to do so, we have to determine the least electronegative element, which in this case is carbon. So we place that in the middle of the Lewis structure, and then you draw the rest of the elements around it, and preferably as spaced out as possible. Once doing so, you fill up the valence electrons around each atom. This is a duet, so it doesn't need any more. This is a duet as well, but these fluorine, they need 6 more to be able to have 8 valence electrons, right? Because you count a bond as 2, and then you go 2, 4, 6, 8. So then you have to do the same for this fluorine as well. So now we have our Lewis structure that is completely filled, but we don't know if this is correct, so we got to be able to prove it. And to do so, we have to determine the amount of valence electrons in this element, or this compound. So to do so, we will first start by writing carbon, hydrogen, and fluorine out. And we know there's only 1 carbon in this compound, so we'll write 1 there. There's 2 hydrogen, and there's 2 fluorine. Now you have to multiply that by the number of valence electrons to get the total valence electrons of this compound. So we know carbon has 4, hydrogen has 1, fluorine has 7. So in total, we have 4 plus 2 plus 14, which equals 20, E negative. So now we go back to our Lewis structure that we drew and confirm that we have 20 valence electrons on our Lewis structure. So we count, including bonds, as 2. We count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So now we know that this Lewis structure is correct. Now we're going to determine the electron pair geometry. And to do so, we have to determine the number of structural pairs. And to do so, we determine our central atom, which is carbon, and we count all the electrons around the carbon. And if there was lone pairs or 2 electrons on the central atom, we have to count that as 1 as well. So now we count 1, 2, 3, 4. There are 4 structural pairs. Oh, I got to be able to make this under.
It's not how you record an